Today we want to discuss isomers and how we can tell whether two structures are isomers or not. When we have isomers, we have a situation where we have two organic compounds that have the same molecular formula. That's really important because it's the first thing you're going to check, but a different arrangement of atoms. They can have the same formula and be just, as we learned last time, flipped around or written just a little bit differently with the branches, and it will appear that it's something different when actually it would be named exactly the same. So isomers have different names, but the same molecular formula. Take, for instance, this situation. If we added up the carbons and hydrogens on all three of these, we would have C5H12. So they meet one of the criteria. But now we've got to make sure that we're dealing with three different compounds, that they have different names as well. Well, this first one is just pure pentane. 5 carbons in a row, the 12 hydrogens attached. Now the next one, yes, it's called isopentane, which is a common name for this, but if you go with the IUPAC naming system, if we named this particular structure, this would actually be a butane. 2-methylbutane to be exact. So this would have a different structure from the first. So definitely these two are isomers. Looking at the third one, if we started numbering carbons, either way we go, we end up with 3 carbons in a row as our max. Well, that means we're dealing with a propane base for this particular molecule. Specifically, if we numbered it as I did just now with the 2 methyl groups on the second carbon, this would be actually 2,2-dimethyl propane. So we've got a pentane, a butane, and a propane. All of them have different names. They are different molecules, but they have the same chemical formula. That's our definition of an isomer. So on these next ones, we need to decide between the two if we're dealing with a situation where they are identical molecules, whether they're isomers, or whether they're molecules that are not isomers and they're not identical either. So look at our first situation. First thing we always want to check is the formula. If we count across, we'll see that this is C4 and that there are 10 hydrogens, so C4H10 for this one. In this particular case, we've got, again, 4 carbons. So it is C4, and if we count up the hydrogens, we count 10 hydrogens. So this does obey one of the criteria, and that's that they have the same chemical formula. But now let's look and see if they are the same molecule. Well, if you count across, this one would end up being a butane. Actually, it's just plain butane. It's all carbons and hydrogens. This one, on the other hand, only has 3 carbons across for its longest chain. So this is actually a propane. Now, it's not pure propane, it's actually 2-methylpropane, but it is a propane. So both criteria, same formula, different names, different compounds. So these are isomers. Look at the next example. We look at the formula, we see that both of these have 2 carbons, they both have 5 hydrogens, and a bromine. So both of them have the same formula. So it obeys one of the criteria. Now let's see if they have different names. And if you look at what we've got here, depending on which way you start the structure, remember those 3 on the end, that bromine hydrogen and the other hydrogen, actually can be rotating, and we'll talk more about that when we get to alkanes. but they are free to move around. So the fact that one bromine is on top and the other bromine is on bottom doesn't matter. If we named this, we would still get the same exact name for these two structures. Since that's true, these are not isomers. They are identical molecules. Finally, on the last one, we look at it and we see formula-wise that this one has 4 carbons and 10 hydrogens, but this one has 5 carbons and 12 hydrogens. These do not obey the rule that they must have the same formula. We don't need to go any further. These are non-isomeric and non-identical. So C, non-isomeric and non-identical. And that's your introduction into isomers in organic chemistry.